Okay, in this tutorial we're going to discuss how to shade from your imagination. Before we do though, let's talk about something called light logic. Light logic is the art and science of how light falls on surfaces. Here's how it works. Imagine that you have a sphere that looks like this. And then imagine you have a light source that's falling slightly from the top and slightly from the side, about 45 degrees. Where the form goes from light to shadow, you're going to have a separation. That separation is called the light break. The light break. So this part of the sphere is going to be obviously in light. This part's going to be in shadow. Let's shade it a little bit. So here's the shadow side. And you can see two kinds of shadows. You're going to see a shadow on the sphere, on the body of the sphere, which is called a body shadow. That's this area here, a body shadow. And then the sphere is going to cast a shadow onto whatever it is sitting on. So the cast shadow on this sphere might run here somewhere. You might see a little tiny bit of cast shadow here as well. This is called a cast shadow. Cast shadow. Now, body shadows have three properties that make them look like body shadows. Cast shadows also have three properties. Let's discuss these properties. So the first thing, if you look at the edge of your body shadow right here, you will notice that the transition is feathered. It's gradual. Why? Because the sphere is gradually turning away from the light source. Less and less photons are hitting the surface of the sphere and it's turning into shadow. So body shadows on round objects are fuzzy. They have soft transitions. They're fuzzy. That's the first property. Second property is that you're going to have a darker value that follows the shape of your light break. So if the light break curves this way, this value is going to curve as well. It's thin, it's darker, it's also fuzzy. That value is called a core shadow. So here's the core shadow. Let's put it, where should we put it? Let's put it right here. Hopefully it's not too confusing. Core shadow. So second property of body shadows is that they have a core shadow. They have cores. Third property is created in effect by the core shadow. It's a little bit of a lighter value at the edge of your sphere here. It's a reflection, a reflected light. So light is hitting the sphere. It's also hitting the table, the stand, whatever the sphere is sitting on, and reflecting back into the shadow, which results in a slightly lighter value on the shadow side. So how much reflected light there's going to be, it sort of depends. Usually there's a lot more here because the reflection is bouncing here, which is really close, and creating a bright reflected light here. Here it might be a little bit darker. Here you might not even see it. It's quite possible. It might start to all kind of look the same. But it still needs to be there in order for the form to appear round in the shadows. So the third property of body shadows is a reflected light. So this is very important. In order for a body shadow to appear three-dimensional, to appear like a body shadow, I need to check off those three properties. So when I'm shading out of my head, I'm thinking about what kind of shadow I'm looking at, and what kind of properties do I need in order for it to appear three-dimensional? These three. Let's discuss cast shadows. So cast shadows also have three properties. So you notice as I've drawn it, the cast shadow has a very, very sharp edge here. That's the first property of cast shadow. Cast shadows are sharp. But cast shadows get diffused as they move away from the light source. So cast shadows usually start very, very sharp and then end up a little bit fuzzier. So first property is sharp. Second property is that they get fuzzier. How much fuzzier? How quickly? Depends on the light source. With direct, strong sunlight, it takes a while. With incandescent indoor light, it happens very, very quickly. Look, if you're dealing with diffuse light, overcast light, or fluorescent light, or something coming from a frosted bulb, the cast shadow is not going to appear sharp at all. But usually under sharp light conditions, cast shadows start sharp and then ultimately start getting diffused. Third property is that cast shadows start really dark. They're usually darker at the point of origin here, which is something called the occlusion. The occlusion shadow. And then, as the cast shadow moves away from the casting object, it gets a little bit lighter. So cast shadows get lighter. So once again, when I'm shading, and I need to shade something that looks like a cast shadow, I'm trying to check off the three properties of cast shadows in order to make the cast shadow look convincing. The sphere is very simple to shade. By practicing shading the sphere, by practicing hitting all of the properties of body shadow and cast shadow while you're shading, it trains you to deal with increasingly more complex forms. So I recommend, as exercise, if you want to draw, if you want to shade better from imagination, learn how to shade basic forms. Spheres. Eggs are excellent practice. So get some eggs out of your fridge and light them really well, shade them, and you will find that once you understand how light works on an egg, you can extrapolate it to increasingly more complex shapes. So those are the shadows. We also need to deal with the lighter area of the sphere, simply called the light. The light also has three properties that make it look like the light. First of all, we have a highlight. So a highlight in this case might be, let's say, somewhere here, like this. That's going to be the lightest value on the sphere. If the sphere is smooth, slightly reflective, our highlight's going to be really shiny, really bright. If the sphere is more matte, then the highlight is going to be more widely distributed, not quite as shiny, not quite as bright. It is always going to be there. Your highlight. Then you have the light, which is not all one value. The lighter area of the sphere is usually brightest where it's directly facing the light source. So it's going to be brighter here. And then gradually, little by little, as the form turns little by little away from the light source, the light gets dimmer. So light is not all one value. Nothing is all one value, frankly. We have constantly shifting, turning form. As a result, we need constantly shifting, changing value. Right? So nothing that is constantly turning, nothing has lots of plane breaks, is going to be consistent in value all the way through. We have the lightest light here, and then little by little it starts moving towards the average light, and then starts going darker and darker until it starts hitting halftone. So, second property is light. Third property is halftone. What is halftone? Halftone is that fuzzy intermediate area in between the light and the shadow. Technically, it belongs neither to the shadow or light. It's an intermediate area. It's where the curvature of our sphere starts getting closer and closer to 90 degrees. So light, if we're looking at a bird's eye view, right? If light is going this way, like this, we're talking about the planes that are getting hit approximately 90 degrees, where only half the sphere, only half the photons are hitting the object. So those are called halftones. They are actually the fuzz. So the fuzzy area in the body shadow and the halftone are actually one and the same thing. So once again, in order for a sphere to appear spherical, it needs to hit all of the properties we were talking about here. So definitely get some simple objects, some spheres, egg shapes, shade them, and practice hitting those properties. It is the first step in learning how to draw from memory.